Hello. In this recording, I'm gonna continue from question 2. So, yeah, in the last video, we were doing how to approach um maths question 1, right? So we dealt with all possible questions for question 1. So let's move on to question 2 now for paper 1. So question 2, what type of question will they ask you? They will ask you laws of exponents. So the main focus here for question 2, the thing that they are testing for question 2 will be laws of exponents. Ne? So even though you'll see solve without the use of a calculator or solve for x or simplify fully, the topic that will be tested question 2 will be laws of exponents. So they can either test it by saying simplify without using a calculator, solve for x, or simplify fully. So let me show you Hapeloko. So that was 2018. Let's look at 2016. What would it say? 2016, they said simplify without using a calculator to see, but they're still testing laws of exponents here. Even here, they say simplify without using a calculator. These are also laws of exponents because they said, and yeah, then yeah, then let's go to 2017. So 2017, even 2017, you can see here, it says simplify without using a calculator, solve for x without using a calculator, then determine if, then show without using a calculator. However, all of these questions will be laws of exponents. So question 2, it clearly laws of exponents. It doesn't matter. They will say, so it did clearly solve, simplify fully without using a calculator, or solve for x without using a calculator. You just have to show that law of exponent without using a calculator. So let's go back to 2018. So what are laws of exponents? So laws of exponents say, number one, they say if you have the same base, right? So if you have the same base, so same base, and so when you have the same base and you are multiplying the term, so you have something like 5. Okay, let me illustrate this. So you have something like 5 squared multiplied by 5, maybe let's say cubed. Yeah. So do you see these things have the same basis, these things? So 5 and 5. So the first law of exponents said if you are multiplying, so there's a multiplication here, and the bases are the same, what do? You add the exponent. So this will be 5. And when you add this, it will be 2 plus 3, which is 5. So that's what I mean. That's the first law of exponent that we have. Then the second one, it says if you are dividing terms with the same base. So make another example. So maybe you have a to the power of let's say 2 again, then divided by a to the power of let's say 3 comma 5. Yeah. So the first one was if the bases are the same and you're multiplying, you add the exponents. Then the second one is if the bases are the same and you're dividing, what do? You subtract the exponent. So because we are dividing, the base will remain the same. Then we subtract the exponent. So 2 minus 3.5 is 1, is minus 1 comma 5. So the answer for this is negative. A is equal, the answer is equal to a to the power of negative 1 comma 5, which is the same as 1 over a to the power of negative 1 comma 5. Ne? So do you see these laws of exponents? They work when there is no plus and minus. So you must not see a plus or a minus for these laws of exponents to work. Ne? So let's continue here. The first type of question you're gonna do is the one that says simplify fully without using a calculator. So how do we assess a question of laws of exponents? Number one, you have to especially when it says simplify, so it's not solve for x, it's simplify, it's a simplified question. The first thing you do is check if you have a plus or a minus. So because that's important. So a plus or a minus, because if you have a plus or a minus, then you cannot use the laws of exponents unless you have one term. So there has to be a multiplication or a division between those two terms for you to use laws of exponents. Ne? So as you can see, 2.1, there's a minus here. So there's more than one term on the numerator. Do you see here? It's 1 and 2 because they are separated by a negative, right? So we cannot use laws of exponents yet. So how would we go about solving this thing without using a calculator? So because there's a negative here, the first thing you have to do in this question is firstly factorize, since you have the same common factor. So you're gonna take out 2x because that's the common factor. But before we do that, let me show you how you can so the first step you can do here to see on a common factor is to actually split the terms on top and in the bottom to see what common factor you have. So you can do this to assess what common factor you have. However, if you can see the common factor without doing the step, then you don't need to do the step. But this is just to illustrate, or you have a common factor here and here. So that's what I mean when I say you have to take it out. So you're gonna say 2x, 2 to the power of x, I mean. And I say 2 to the power of x. So it's 2 to the power of x. Then open bracket. What's left is 2 to the power of negative 3 minus 3 times 2 to the power of 1. Then 2x times so it's negative 2 here, negative 2. Okay, so do you see now that we took out like a common factor, this and this, like 2x, then open bracket this? Do you see now we've created one term? Because this negative is within a bracket. As long as a negative is within a bracket, then this whole thing here is one term. So because you change this into one term, that means that you can start multiplying or dividing with the denominators. So this one is the same as this one, right? And this is one term, this is one term, so we can cancel it out because the denominator is the same as the numerator. Then what's left? What's left is 1 over 80. Or before I go there, let me just show you where I got this 1 over 8 from. So it's 2 negative 3 it's not -3, it's positive here because you took it to the denominator. So when you take it to the denominator, it becomes positive. Then minus 6 divided by 1 over 2 to the power of 2. And after here, you just solve this thing normally using yeah. So this one you're gonna use normal LCM and maths here. So this is gonna be 1 over 8, then minus 6 1 over 4 over 1 over 4. Then you're gonna simplify this using LCM. So let me show you the answer. You see here, from here on, they used the LCM method to calculate this, but you can put this in the calculator because the reason why they say simplify without using a calculator, they wanted to see if you can reach to this step without using a calculator. That's what they were testing. Okay, so that's the first question when it says simplify fully without the use of a calculator. So that's what you do. Let's see if they have a similar question in 2017. Yeah, I wanna, even here they say simplify fully without using a calculator. So what are you gonna do here? Because it's laws of exponent, it's question 2, it's laws of exponent. You have to check firstly if there's a plus or minus. So to make sure there's one term. Do you see there's a minus here? So there's 2 terms, 1 and 2. So what do you have to do? You have to check if you have a common factor, right? So we have a common factor here. It's 3m. Do you see it's m here? 3m. I mean m to the power of 3. M to the power of 3, m to the power of 3. So you're gonna do this step the same way we did this side. Then yeah, cancel it out. So here you can just split it up to see which one is a common factor, or you can jump straight to the step that we did here. Then even here, do you see, say simplify without using a calculator? So 5 and 2, 8. Do you see this one on top? This is how many terms? This is one term because there's a multiplication. So it's not separated by a plus or a minus. So the operation here is a multiplication. So which means this is one term. However, in the denominator, there's a separation here of like a minus. So do you see we have 2 terms because this and this are 2 terms. This is a multiplication. So this and this, these terms are not separated. This is one term. A term is separated by a plus or a minus. So that's the first thing you see. Like go 2017 memo, or when we were separated by a minus, but it was the numerator this time. That's why we took out the common factor in the numerator. So here, do you see here is the denominator? That's why we're going to take out the common factor in the denominator, which is 10 to the power of a. That's what you take out. So now, there's another rule for laws of exponents. Ne? It says if you have so if you have the same exponent ne, and you're multiplying, you can so if you have the same exponent, so something like a and a, one, then you can multiply the bases, then the exponent will remain the same. So this will be equals to 10a. Why? Because the exponent is the same. So when the exponents are the same, you multiply the bases if there's a multiplication sign. Then if there was a division sign, you're going to divide the bases. So another example, so if maybe it was let me use a number this time, 2 to the power of 2, then multiplied by maybe 10 to the power of 2. So the exponents are the same and you are multiplying, so you multiply the bases. So 2 times 10 is 20. Then the exponent remains the same as 2. So this is what I meant when I say this is another law of exponent. So in this question here, what you are going to do here is you're going to take out 10 as your common factor, right? 10a. Then after taking it out, you're going to say 5 in the numerator times so 5a times 5 to the power of negative 2, right? And times 2a times 2 to the power of 2. Yeah. So this is how you do it. Then divide it by, then you're going to take out your 10 here, right? So there's two ways to do this. You could either multiply this 5a with this 2a, since there's no plus or minus, so there's no restrictions to what you can multiply. So you could have said, because these two things are the same, so these two exponents are the same, you can multiply 2 and 5. But do you see, between this 5 and this 2, these exponents are not the same, because this is 2, this is negative 2, so you can multiply these two. So you could have either said 5 multiplied by 2 is 10, which is 10a. Then this 10a will cancel out with the 10a that you're going to take out here. Or you could have said 10a is the same as, so you're going to look for the factors of 10, which is 2 and 5, right? So it's 1 and 10 and 2 and 5. So obviously 1 and 10, you won't use it because we use 10 here. So, or 2 and 5. So you're going to do this. So basically you're going to change this 10 into this, then cancel out this with the numerator. That's another way of doing it. However, if you see simplify fully without using a calculator, you know it's this type of question. So even here, do you see here? It says simplify without using a calculator. There's a minus here. So that means that there is a common factor somewhere. So let me show you. So they said the square root of 6. So the square root of 27 m to the power of 6. So what do you do here? You're gonna say I get a square. Do you know what a square root looks like when you write it as an exponent? So I think it's better to change the set into an exponent here by saying 27 m to the power of 6. So the exponent there is a half, right? Because it's a square root sign. Then this side is the same thing. So 48 m 6, then to the power of a half. Then you're gonna do the same thing for the denominator, right? So I'll continue the numerator. I won't do the denominator. So what's the exponents for this? So you're gonna say 27 to the power of half. I get this exponent multiplies everything inside. So to the power of half multiplied by m to the power of 6 multiplied by the power of a half. So this is gonna be 6 divided by 2. So it's gonna be m to the power of 3 minus 48 to the power of half, because it's essentially 48 times 1, right? Because it's power of 1. Then here it's 1. So 1 times a half is a half. Then 6 times a half is 3. Then 6 times a half is 3. So here it's gonna be m to the power of 3. So what you're gonna do here, because m and m to the power of 3 they are the same, So you're gonna take out the a common factor. So this is the common factor, m to the power of 3, take out m to the power of 3. Even in the denominator, you're gonna have m to the power of 3. Then after, you're gonna cancel out those 3 m's and then continue on with the question. So solve the question. So yeah, those are those types of questions. Yeah. Okay. So let's move on. Yeah, let's move on. Okay. So that's the first type of question. And the second type, it says solve for x. So solve for x here, you're gonna solve for x normally here. So with this one, what you're gonna do is you're gonna take this negative 16 to the other side. So you're gonna have 2 is equals to 16 x to the power of negative 3 over 2, right? Then divide both sides by 16. So it's gonna be 1 over 8 is equals to x to the power of negative 3 over 2. So here, how do we continue? We want x, right? So we want to take out this exponent. So we multiply with the inverse of this exponent. So we are gonna multiply this exponent with the inverse of exponent so that it cancels out. So we're gonna multiply it with negative. So we're gonna multiply it with the power of negative 2 over 3. So negative 2 over 3. So this will cancel out this, and this will cancel out this. So x is equals to that. So you can just put this into a calculator and you'll get your answer. So that will be equals to 4. So x is equals to 4 for this one. Then yeah, let's move on. So that one was fairly simple. 2.2. So with this one, it says solve for x. And do we see that x is in the exponent and it's in 2 numbers? So what are we gonna do here? The first thing we do is check if these numbers are the same, right? So 4 and 2 are not the same. So, but can you change 4 into 2? Yes, you can. So 4 is the same as 2 to the power of 2. So this is gonna be to the power of 2 what x plus 80, which is equals to 9 times 2x. So do you remember in our last video, I said there are 2 types of lead questions. There's one where you have maybe a bracket or a variable or a term in the numerator, then plus, then another term in the denominator. Then the second one is when you have this. So you have you see here, if you solve for x here, we won't be able to solve for x because this does not have the 2x one. So even if we take this thing to the other side and take out the common factor, it won't work. So what do we do with this one? It's a lead type of question. This is the second type of lead question. So if you have basically, do you see this x? We can't solve it. You see it's hard to solve it. Like I said, the lead type of question, number one, you're gonna see because it's hard to solve. So you can't solve this x no matter what you do. Nje. You can try, Mari. You won't go anywhere solving this x normally. So what you do after you determine that you can solve it normally, you check if it's a let question. So a let question, like I said, it's number one. The first one is when you have a term. So one term is in the numerator and you're adding a term in the denominator. So you're gonna change those terms into a variable and solve them quickly. I get it. Then the second type is when, so you have something like 2x, then you have its square here, then you can use a let type of question. So what are we gonna do here? We're gonna say let 2x, so 2 to the power of x, ne? Let 2 to the power of x equals to k, ne? So let 2 to the power of x equal k. So every time we see 2x, we're gonna put k, right? So how many 2x's are here? I get it. 2 to the power of 2x is the same as 2 to the power of x multiplied by 2 to the power of x. Why do we say this and this are the same? Because the bases are the same. And if the bases are the same and the bases are the same, you can add the exponents, right? So this and this is x plus x plus x is 2x. So this is equals to how many k's? 2k. So it's k times k, right? K times k, which is what? K squared. So this is the same as k squared, then plus 8. Then how many 2 to the power of x do we have here? We have 1, so it's only k here. Yeah. Then you solve for k. After you solve for k, you're gonna substitute this 2 to the power of x. Then after solve for x. So let me show you in the memo like we did here. You see, okay, this is 2.1. Okay. Yeah, here. So you let 2 to the power of x equal to k. Then you solve for k. So you get k is equal to 8 or k is equal to 1. Then k is equal to 2 to the power of x. I get it. These are now easy, so you can work with. Then you get your two answers. That's how they got those answers there. So that's the second type of let question you can get. Let's move on. Okay. Even here, do you see here? It's the same thing here that happened. So here it was gonna be 2 to the power of 2x. Then you're gonna change 2. So you're gonna say let 2 to the power of 2x equal k. Then substitute k, solve for k, substitute back the 2 to the power of x and solve for x. Same way as that one. Then this one, yeah, you're just gonna solve for x normally. So you're gonna multiply this by the power of -4/3 on both sides and get your answer. Yeah. So yeah. Then this one, 2.2.3. So let's do this one. So it says so this is the same as saying 9 to the power of 1 over x, ne? 1 over x, right? Which is equals to 243. So how do we do this? You can say 243, then in your calculator, then press equals to shift, then check the press shift, then fact. then you'll see that that 2 to the power of that 243 is the same as 3 to the power of 5. Then this one is the same as 3 to the power of 2, right? So this is 3 to the power of 2 multiplied by 1 over x, then 3 to the power of 2 over x. So this 2 and this 1 over x will multiply, then all over 3 to the power of 5. So 2 over x is equals to 5. Why? Because these two are the same. So if these two are the same, you can equate the exponents. Then therefore x, so you're gonna solve for x normally. So therefore x is equals to 2 over 5. Yeah. Okay. Then so that's it. So that's for solving for x. Then you also have a simplified fully here, which you essentially also do the same way. Mare, let me do it so that I illustrate with this one. So with this one, we're gonna change this third into an exponent really. So this is the same as saying p squared minus q squared, so all of it to the power of half, I get, then multiplied by this, so p plus p q to the power of 5, then 5 over 2. Then this one will remain the same, co-denominating, it will remain the same, this one. So what will be the next step after here? You're going to change this thing firstly, because this is the difference between two squares, so you're going to factorize here. So it's p minus q to the power of p minus q. Then you're going to have p plus p q. Then this whole thing is to the power of what? To the power of a half, right? So because it's to the power of a half, this half is going to multiply every bracket, right? So this is the same as basically this. So this is the same as saying this bracket to the power of a half multiplied by this bracket to the power of a half. Yeah. It goes with the that law of exponent, that last law of exponent. Why? Because the exponents are equal, so you can multiply the bases. And so this is the same. Then from there onwards, because this is the numerator, this and this are identical, so this is going to cancel out the denominator, and this is identical to that, so this will add to that. So you're going to say half plus 5 over 2. So it's going to be p to the power of p plus q to the power of 3. That's the answer. So let's go to the, you see here, Then they got half p's. This one minus cancels out this. The basis of these two things are the same, so we add the exponent. So half plus 5 over 2, like they did here, that's equals to 3. That's the answer. So that's basically question 2. Question 2, they will ask you laws of exponents only. It will only be laws of exponents that they will be testing. So that's how to approach question 2. Let's move on. All right. Okay. So let's move on. Okay. Okay. Yeah. Okay. So question 3, it says so that's question 2. So question 2, they will ask laws of exponents. So question 3, what will they ask? And question 4. So question 3 and 4, it will be number patterns. So yeah, number patterns. So question 3 and 4, it will be number patterns. So it's either a linear number pattern or a quadratic number pattern. And I'll just go through how you approach this question. So question 3, it says determine the general term Tn of the linear pattern. So how are you gonna approach this question? So the first thing they said, determine the linear equation of this pattern. So patterns, linear, you're gonna write it down like they did here. Then you're gonna find the common difference, right? Which is -5. So this -5 is the common difference in this question here. See, so you're gonna say this. So from 7 to 2 is -5. Then from 2 to -3 is -5. So that's the common difference. Then Tn, because this is a linear pattern, what's the general form for Tn? Tn is equals to A plus An plus B, right? Then so Tn is equal to An plus B. Then what is A? A is the is the is the common difference, right? So A is the -5. That's why we put the -5 here. So you're gonna put the A there, number 1. Then how do we get to B? Simple. We saying from -5. I get A is -5, which are our common difference. So we say from our common difference, how do we get to this first term? So from -5, how do we get to 7? We have to add 12. That's why they got that plus 12. So from this common difference to 7, how do we get to 7? By adding 12. That's why they got this 12. Then this A is the common difference. So that's how you determine the general term for the linear pattern. Then calculate the value of T20. So, okay, before I move on, do you see that the general term for a linear pattern, the general term for the linear pattern, this is the same as like this is the same as a straight line graph formula. Do you see where Tn is y and n is x? I just want you to see that this is the same as a linear function, this thing. So calculate the value of T20. So what they are saying is wherever there is n, you must substitute 20, right? So we want to substitute 20 where there is n in that formula that you just calculated. So that's why they did this, substituted the 20. Move on. So 3.1.3, it says which term in the pattern has the value -138. So you're gonna equate this thing to the equation. So you're gonna say negative 108 is equals to negative 5n plus 12. Then you're gonna calculate the value of n from this thing, like they did here. Then we go to 3.2. It says 6, what's this, 2x plus 1 and 3x minus 3 are the first three terms of a linear pattern. Calculate the value of x. So they're telling us these are the first three terms of a linear pattern. And we know, what do we know about a linear pattern? A linear pattern has something called a common difference. So that's what they are trying, that's the principle they are trying to test here. Do you know what a common difference means? On one. So do you know what is a common difference? And do you know that a linear pattern has a common difference? So how do you do this? Normally we say this, right, minus that. So 2x plus 1 minus 6 is 2x minus 5, right? That's the difference here. Then this minus that, so 3x minus 3 minus this bracket, so that's going to be equal to, so it's going to be 3x minus 2x, which is x, and negative 3 minus 1, which is minus 4, right? We said these two things must be equal, so these two must be equal, because why? They are called common differences, so they have to be the same, just like here when we got this uh, 5 here. Do you see this negative 5 is equal to this negative 5? That's what we mean when you say common difference. So these two must be equal in order for this thing to be a linear pattern. So you're gonna say 2x minus 5 is equals to x minus 4. Why? Because these two must be equal. They are common differences. So let's calculate x. So x will be equals to 1. So x is 1. Yeah. So that's how you approach a linear pattern. So a linear pattern, it's, you approach it the same as a linear function. It's not that hard. So we can move on. So do you see even this one? Okay, here they asked you a quadratic. Let's move on to a linear. So question 4, they asked you a linear. Do you see linear? They say write down the fourth term. Obviously here the common difference is negative 4. So the fourth term here will be 6. Determine the general term of the pattern. The common difference here is negative 4. So you're gonna say Tn is equals to an plus b. So, and the negative 4 is the common difference. So you're gonna say Tn is equals to negative 4n. And how do we get to 18 from negative 4? So we get to 18 by adding 22, right? So we have to add 22 from negative 4 to get to 18. So the general form will be Tn is equals to negative 4n plus 22. Then this is the same thing. You're gonna put this in your formula. So on Tn, then calculate n. Then it says if this linear pattern forms the first differences of a quadratic pattern, Qn, determine the first differences between Q59 and Q. Okay, so this is like a question they may ask you, the thing, but we'll do this one after I show you the quadratic pattern. So that's what they have for 2017. Do you see another linear? Oh, there's 2016, another linear pattern. Let's check for 2017. There's you have another linear pattern here. The same thing. So here you're gonna do it the same way as I did that one. So you're gonna find the common differences here and just equate the common differences. Then you'll get the values of x and y. Ne? You're gonna get three equations here. So x minus 3, y minus x, and 30 minus y. Three equations. So you're gonna solve for x and y simultaneously, but you're gonna get one value for x and one value for y. So that's basically linear patterns. Ne? That's linear patterns. Now I'm gonna move on to the next type of patterns, which are quadratic patterns. So what's the difference between a quadratic pattern and a linear pattern? The first thing is that, or the main difference is that the quadratic pattern has a second common difference, while a linear pattern has only the first common difference. Ne? So for a quadratic pattern, you won't see a constant first difference, but you'll see a constant second difference, meaning the first difference will not be the same, but the second one will be the same. So let's do this question. It says a quadratic number pattern has a constant second difference of 1, right? Show that p is equal to 7 and q is equal to 16. So in this thing. So do you agree for a quadratic number pattern, they will give you like a pattern, right? So like this one. So they'll give you a pattern like this one here. So here they said P, then 11, then Q, yeah, 20, 22. Yeah. So they said prove that this is so what does this mean? Number one, this and this, so this and this, I get this P minus 4, so P minus 4, that's the first difference for this one. Then this is 11, right? This is 11 minus P, right? Then you can do this. So this is Q minus 11. And this is the same as 22 minus Q. Then you're gonna find another minus. So this minus that. So this minus that. So it's gonna be 15 minus 2P. Again, when you say this minus, it's gonna be negative P plus 4. So 4 plus 11 is 15. Negative P is negative 2P. So they told us for the second difference is 1, right? So this must be equal to how much? 1, right? Since it's the common difference. They told us that the second constant difference is 1. So this must be equal to 1. Yeah. So from there on, you're gonna calculate P. So it's negative 2P is equals to negative 14. Then divide by 2 on both sides. Yeah, divide by 2 on both sides. Then you're gonna get that P is equals to this 7. So you showed that P is equals to 7. That's how you show that P is equals to 7. Because we know for a quadratic equation, right, that this part here is the second constant difference, and they told us that it's 1 here. That's why we were able to calculate it there. Okay. Let's continue. So here what do we have? This minus that, right? So this is gonna be positive 11, so 33 here. Then minus 2q, right? Minus 2q. So the same thing, this is a constant, a common constant difference, and this must be equal to 1. So you're gonna equate this to 1, and then solve for q. Then if you do that, you're still gonna get this answer of 16. So that's how you do that type of question. Ne? Okay, before I erase here, so what do we have for P? So for P, we have 7, ne? And Q, we have 16. So let's just write them down. P 7 and Q is 16. And let's remove these differences here. Okay. 7 minus 4 is 3. 11 minus 7 is 4. 16 minus 11 is 5. And 22 minus 16 is 6. So do you see here the second common constant difference is 1 for all of them, right? Like I said, a quadratic number pattern has a second constant difference. So what do we do to calculate the general term for a quadratic pattern? Again, it looks like this, which looks the same as like a quadratic function. It's just that we are using in terms of Tn and n. So a n plus b n plus c, right? So it's this way. This is the general term for it. So how do we calculate the general term for quadratic pattern? We know that this thing must be equal to what? 2a. So this one must be equal to 2a, which is the constant second difference. The first so this first term for calculating the first difference must be equals to 3a plus b. So for 3a plus b, it must always be equal to this one, not this one, and not now 4 or this one. So this one, the difference between this term and this term, not this one and this one. So that's equals to 3a plus b. Then a plus b plus c. Yeah, plus c, I mean, must be equals to this one, the first term, not this one, the first term. So let's start. 2, they said 2a is equals to 1, right? So if 2a is equals to 1, a is equals to what? Half. So a is equals to a is equals to 1 over 2, which is a half. Then 3a. So 3a is 3.5, right? 3.5, 3a, which is 3.5 plus b, we don't know b. Must be equals to what? 3. So we take this thing to the other side. B is equals to negative 3 over 2, right? Then we move on. A, which is a half, plus b, which is so a, which is a half, plus b, which is negative 3 over 2, plus c, which we don't know, must be equals to 4. So c is equals to 5. So what's the general term for this? Tn is equals to half n squared. So half n squared, this must be squared because quadratic. So half n squared plus minus 3 over 2n plus 5. So that's the general form for this pattern here. Then they said determine the value of n. Okay, let's just go to the memo and so this is the first one they did here. So like the way we did it there, let's move on. See, yeah, it's plus. I made a mistake here. This is supposed to be a positive. Yeah. So b is 3 over 2, then c is 2. Then from there on, you substitute inside. So you substitute this inside. Just make sure here, and I made a mistake here. This thing, when you take it this side, it becomes negative 1, negative 1,5. So 3 minus 1,5 is positive 1,5. So it will affect also the C calculation. So just be with it. Then here, the next question, what did they say? They said determine the value of, so if Tn, so the same way you're gonna do the one for linear, you do the same for air quadratic n. Then quadratic pattern, like I said, is the same as like a quadratic function. So just keep that in mind. Then, but if the sum of two consecutive terms in a pattern is 1,227, calculate the difference between these terms. Okay, so this one I won't do this one, and because they don't ask it every time. Let's just check here. Show that all the terms are positive, between which two consecutive terms will the first difference be this. Okay. It seems like they're asking it, Vele, this type of question. I just wanted to check if they ask it. So all right. Okay. Okay. Don't forget this thing here, the quadratic, I mean number pattern, like I said, is the same as what do you call this? A quadratic number pattern is the same as a quadratic formula, a normal like quadratic formula, right? So how would you go about like doing this thing here, right? They are telling us that the sum, if the sum of two consecutive terms in the pattern is that, right, calculate the difference between these two terms. So how do you approach this question? So they say the sum of two terms in this pattern. They didn't tell us what are the two terms. So that's why here they added these two terms. So do you see this is the same? Let me just illustrate here. This portion here is the formula, right? And also this portion here is the next term plus the formula, right? So if you have, let's say 4 here, 4, this will be 5, which value goes according to what they say here, because they said if the sum of two consecutive terms in a pattern. So what are two consecutive terms? So term 1 and 2, or a term 5 and 6, or term 638 and term 639. So it's just, what they mean is just they are next to each other. So if the other one is n, the next one should be n plus 1. That's why they used n plus 1 here. So it must be equals to 1,227. Then from there on, they calculated n here, the n. they got two n's. Obviously, you're gonna take the positive one because you can't have a negative n. Then after they calculated this n here, they were able to see. So basically, by calculating this n here, you are able to see what two terms you are working with. I get here, they just said terms must be equal to that. So by calculating this n, you can see what terms you are working with. So you can substitute this thing for term number one. So I get this is 33, right? So the first one you'll substitute 33. Then the second one you're gonna say minus, then the one that has 34. So like the way they did it here. So let me go through this type of question again. It says the sum of two consecutive terms in a pattern is 1,227. Calculate the difference between these two terms, right? So number one, you don't know what those two terms are, those two consecutive terms are. That's why you have to calculate what are those two consecutive terms so that you know the difference between those two. So how do you calculate what term is it in? So you know that these terms are consecutive. So what does consecutive mean? It means that they are next to each other. So 4 or 5 or 9 or 10 or 1, they are just next to each other. So you know that this 127, I get it's derived from these two terms. So the first term, what are you gonna do? You're gonna say, what is the general form of this quadratic pattern? The general form is this thing, right? Half n, then n squared plus 3 over 2n plus 2. That's the general form for it. So for the first term, because you don't know what those terms are, so for the first one, it's just n because you don't know what it is. But for the second consecutive term, you know that for the second consecutive term, it has to be that n plus 1 because, like I said, it's from term 5 or term 4 or 5, then 9 or 10. So they are adjacent to each other, they're next to each other. So that's why they used 1 here. Then this must be equal to 1027. Then after using this, you're going to calculate what the n. So the n here. What is the n? The n is the term. So you know that n here, it means term 33, right? So what is the consecutive term next to 33? It's 34, right? So what did the question say? It says calculate the difference between these two terms. So you're gonna say term 34 minus term 33. And just substitute those terms into his form, into his equation. That's where they got this 34 and this 33. Then they minus, then they got the answer. So these types of questions, they are specific to a question. That's why I didn't want to do them, because they are specific to a question. However, in terms of like generally, so question 3 and question 4 will be number patterns. So one will be a linear, one will be a quadratic. Then for a quadratic and linear, they will always ask you a 4-mark question like this, or like this. So and like this. So they'll ask you maybe 6 easy marks, then 4 marks the hard. And the same thing this side. They're gonna maybe ask you 10 easy marks, then they're gonna give you 4 hard ones. So you must expect like questions as well for quadratic patterns, but they are always gonna be test specific. So they'll change these ones here. They'll just show like, do you know a quadratic pattern is actually what do you call this, a quadratic function. So it's the same as like a parabola. Yeah. So yeah, that's question 3 and 4. It will be linear patterns and number patterns. So yeah, for today's recording, let's end here. Then next time I'll be doing functions, how to approach functions. Okay.